What if we have two random variables, x and y? Well, we can find the expected value of x squared, and the variance of x, as well as the expected value of y squared, and the variance of y. And since linearity still holds, we know the expected value of the sum is the sum of the expected values. But what about the expected value of the product? So by definition, the expected value of the product will be the sum of the products of the payoffs with the probabilities. Now, suppose that x and y are independent random variables. Then the probability of the conjunction is just going to be the product of the probabilities. And so we can rewrite that expected value of the product as... Now, this internal sum can be regarded as the sum over all possible values y given a specific value of x. So that means x and the probability that a random variable equals x are fixed values and could be factored out of the sum. And now we have this sum, that's the product of the payoffs and the probabilities. Well, that's just going to be the expected value of y. And since that's a constant, we can factor it out, getting... And by the same argument, here we have the sum of the products of the payoffs and the probabilities, so that'll just be the expected value of x. And so, if x and y are independent random variables, the expected value of the product is the product of the expected values. For example, suppose we have two fair six-sided dice, and we multiply the numbers shown. Let's find the expected value of the product. So let x and y be the numbers shown. We know that the expected value of x and the expected value of y are both 3.5, and the numbers shown are independent, so the expected value of the product is the product of the expected values. What about the variance? The variance of a single random variable is computed as, if we let z equal x plus y, well, z is still a random variable, and so our variance will be, in other words, the variance of the sum will still be the expected value of the square of the sum minus the square of the expected value. So let's consider the problem of rolling two six-sided dice and adding them. Let's find the variance of the sum. So let x be the number on the first die and y the number on the second. The variance of the sum is the expected value of the square minus the square of the expected value. Now, since x is a linear operator, then the expected value of the sum is just going to be the sum of the expected values. And again, since e is a linear operator, then e of the square is going to be, first of all, e of the expanded version, and then we can sum the individual terms. We need the expected value of x squared. And since x and y are independent, this expected value of the product is the product of the expected values, and filling in our numbers we get. And so we can compute our variance.